Guys, can you just sit for 10 minutes? We'll explain superconductors in this time. Possible? Whatever is left, we will continue maybe next class. Just before man. If you guys can sit for just 10 more minutes, we'll finish that.
In 10 more minutes, there will be another class.
Exactly, this is I'm saying just 10 minutes, not 20 minutes.
Yeah, sure.
Yeah, if not
Okay, fine.
एक साथ सारे फ्लो में होगा तो ज़्यादा अच्छा होगा.
Is it alright?
Yes.
मुझे अपने नोट्स का एक फोटो लेना है. होगी भेजूंगा तेरे नोट्स का फोटो है भेजूंगा. वहाँ पे फोटो नहीं था बोर्ड का वीडियो है पूरा वीडियो पर है. ये क्या पूरा चीज़ रिकॉर्ड कर रहे हैं. मैं भेज दूँगा.
ये वाला फाइल में था ना वो कैसे
भाई सब कुछ भेजा जाएगा. मेल हो जाएगा. फाइल पूरी फुल HD 60 FPS पर रिकॉर्ड की है.
हाँ भाई फुल HD है 60 FPS एकदम.
ये तो एक ही रिकॉर्ड कर दो. कितना तेज मीटर है
प्रोफेसर वर्मा.
So the topic I'm going to teach is superconductors, which is still a very vast, not vastly in-depth in the research. It's still a very good research field if you want to go there. And the thing about superconductors is they are very different from insulator conductors and semiconductors. So what happened was 1911, Dutch physicist called O'Neill, in 1911 was studying with a metal, mercury, and he was just making a graph of resistance, which I am going to do with rho, ohm, and this is temperature. So he was studying how it affects the temperature. So what he noticed was the sudden decrease of resistance when the decrease the temperature, and it's directly proportional. So he noticed still a temperature which is little say for now with T, and after that the resistance suddenly decreased. For mercury it was 4.2 Kelvin. So he named this temperature as critical temperature, which is critical temperature for a metal to become a superconductor. So at this temperature, he noticed that the resistance became practically zero. So after what he noticed is the resistance became zero and the metal was showing a new effect which he named superconductivity. And in this phase, the metal was able to conduct electricity without applying any kind of potential. So due to Ohm's law, Ohm's law is this, and the resistance becomes zero. So by that voltage is zero, but still there was a current which was a super current, which is a super current, and this he named superconductors. So that's how it got discovered in 1911. And then after that there was a German physicist called Michner. He did his research in 1933 about superconductors. What are the other properties of superconductors? So So 1933, what Michner observed was when he took a material, let's assume it to be a sphere, a conductor. This is a conductor. And when he applied an external magnetic field, so in a conductor, external magnetic field goes to the material, right? So it's just like this. So external magnetic field. But when we like decrease the temperature to the critical temperature, this is the critical temperature of mercury or other substances can differ 3 Kelvin, 10, 20, it can differ. So in the superconductor, so let us assume that we applied a magnetic field of 5 Tesla. Okay. So 5 Tesla. So when we will read the magnetic field here, it will show 5 Tesla, right? Because it's a constant magnetic field that he is applying, constant external magnetic field. But in the superconductor, he noticed that the magnetic field over here was just doubled or was more than 5 Tesla. So how can this happen? Because the conductor allows the magnetic field to pass through them, so it should be constant. So from there, he concluded that superconductors are perfect diamagnetic substances. So here it concluded that it is a perfect magnetic susceptibility being -1. So for the other diamagnetic substance, it's small, but not 1. It's small and negative, but it's not 1. Susceptibility is the material's tendency to react when any kind of magnetic field is applied to the object. Okay. This was measured applied. Okay. So this was like this happens due to its dynamic substance. So any kind of this be a superconductor and any kind of perfect magnet that you put here. Perfect magnet has a constant magnetic field. So any kind of magnet you put here. Okay. Close towards this because it's a diamagnetic substance. Perfect. So it exerts an external magnetic field. I'll explain how it happens. It happens due to